Okay, good. So this is Avant. I'm Anders. We're glad to be here today, talking a little bit about microservices, do's and don'ts, those kinds of things. It's a hot topic right now, and of course for a lot of people, everybody's trying to figure out, what's my microservices strategy? The same way we had to figure out the cloud strategy and all the other kind of strategies that we have. And of course, one tool does not solve all problems. But it is an interesting tool, an interesting kind of process that you can use, so we'll dig into that a little bit. I suspect some of this will be kind of intro material for a lot of people in the room, but we'll cover it nonetheless. So microservices, it's a way for building distributed network services. The idea is to basically have each service do one thing, do it well, run separately in its own process, probably on its own system. They should be independently deployable and independently developable. If they're not, then you're going to lose out on a lot of the benefits, potential benefits, of microservices. And the idea is, get all those things together that change for the same reason and move all the things that change for different reasons away. So what's cool about it? Well, it's really divide and conquer, right? It's take a problem and get it down to its constituent pieces and solve them independently. Yeah. Sure. All right, I'll be over here. So divide and conquer, right? I mean, divide a problem down into its constituent pieces and get going on it. And the idea is that you want loose coupling between these services. One of the nice things about that is you get to choose the appropriate tooling to solve whatever problem you're trying to solve. You don't have to pick one tool chain to solve every problem that you have in front of you. You can scale these things independently of each other. So you don't have to scale everything to scale something, which is a good deal. And again, these things can have life cycles independent of each other. So you may have services that you touch all the time because they're evolving quickly, you're adding functionality, those kinds of things. And you may have services that you haven't touched for years, avatar service, or what have you. One of the nice things about the independent toolchain bit is you can adopt new technologies more quickly, right? Because you don't have to switch over the entire monolith from using, COBOL to using whatever the newfangled language of today is. In general, it's kind of been proven that smaller, more autonomous teams are more productive. And microservices in the right, kind of environment definitely lends themselves to that. And what's more, if you're doing a scalable application and you can scale these individual microservices, you're going to get better resource utilization, right? Because you're not going to have a bunch of state and code and other types of things sitting on a machine being underutilized because you had to scale up to for that one particular code path to be more scalable than the other. So better resource utilization. Oftentimes people say, well, wasn't this what service-oriented architectures was supposed to do for us, or agent architectures, or name any of a number of different kind of applications. And yeah, I mean it's kind of true, right? I mean SOA was meant to help with the kind of the monolithic application. I would say outside of certain vendor spaces, no good consensus was ever achieved, and it became more about my bus is bigger than your bus kind of a thing in the vendor space. And there was a lot of kind of lock-in associated with SOA because it was use my middleware, live in my ecosystem. Whereas I think microservices has really evolved out of real-world problem solving. So there's a lot of sort of standards approaches, there's a lot of open source involved, a lot of very, very loose coupling as opposed to tightly binding yourself to certain kinds of messaging implications and those kinds of things. So, looking at, what are other ways that you could solve this problem? The problem, being defined as I have this huge monolith. If I have to make any change, I have to deploy the whole damn thing. If any piece of it is unstable, then I can't, deploy the other pieces of it because it's all one big piece, those kinds of problems. So why don't I just, use good coding practices and modularize the hell out of my code and use shared libraries or jars or what have you? Well, there are some challenges to that. There are some benefits that you don't get by going down that road. First one's, technological coupling, right? You're no longer really free to use the kind of tooling that you want to use to solve each problem. And yeah, you can call a shared object, from inside of a piece of Java code or native from Perl or what have you. but really you're definitely in a state where you're driving yourself a little bit down the technological coupling road, which is not a place you want to do. And then you do get yourself into a scenario where you probably can't still deploy anything without deploying everything, right? You've got lots of code changes that are happening, and unless you pay very specific attention to how you're versioning these modules and how they fit together and how they're compatible with each other forwards and backwards and so on, you may very well find yourself in a place where you still have to deploy everything just to deploy anything. And it does make it a lot easier to kind of introduce unintentional API coupling, where you might decide to call a method in some library that you really ought to be calling a method kind of higher up in a different library to get the right response. So it makes it easier to kind of violate API boundaries and those kinds of things. So code reuse is definitely a good thing, and any properly architected microarchitectural application will promote and do code reuse, but not necessarily by having the source all in one place and those kinds of things. It'll be more through artifact sharing and shared libraries and those kinds of things. It's just not a foundation for how to architect a whole application. But we've been doing monolithic apps for kind of a long time now, so they can't just be all suck, right? I mean, there has to be something good about them. They can be a lot easier to test, right? You only have generally one process to get up and running. Yeah, maybe the database too, maybe a web server or something like that. But compared to a microservices application with 219 different microservices, with some are written in Python, some are written in Perl, some in Java, some in C++. You see where I'm going with that. They can be easier to develop, right? You don't have to worry so much in a monolithic application about, ooh, is this going to go over the wire? Can I, if I send this object over the wire, is it too big? Should I be sending just some attributes of the object? Those kinds of things, because so much of what you do is pass by reference instead of pass by value. And of course, they can be easier to deploy. I mean, surely if I have a WAR file that contains my application and I drop it into my JBoss server or Jetty or what have you, that's quite a bit easier than I have my 246 different microservice applications or services that I need to deploy, and sometimes in a particular order, or I have to write it so that they're resistant to those kinds of things. So monolithic applications are not all bad, but the things that we've covered so far, you can't deploy anything until you deploy everything, right? It's harder to learn and understand this code. It's a lot easier to introduce spaghetti code. It's a lot harder to adopt new technologies, and you got to scale everything to scale anything. So the usual kind of bad things apply. So I've talked a little bit about the divide and conquer problem. So the natural question to ask is, was Fred Brooks full of crap? No, definitely not. The problem remains. But if you have the amount of, if you have the right number of people and you've decomposed an application properly, you can definitely skirt around, the kind of the mythical man-month limitations, right? If you've truly got independent teams working independently, and they've got APIs that they service that are carefully, nurtured and cultured and all of those kinds of things, then yeah. And you definitely see the graph on the right is from last year's State of DevOps report. Put out by ITRev and Puppet Labs. And one of the leading indicators of success for a software organization, as measured by those folks, is how many deployments per day per developer do you manage to do, right? And so the idea that you would be able to do, kind of the big, see if I can get the laser working. No, kind of weak. The idea that I could get thousands of deployments done every single day without something like a microservices architecture is challenging. You've got to be really, really on top of your game if you're going to do that in a monolithic application. But some caveats apply, right? If you've got an organization with 50 software developers, and you decide that your microservices application is going to be composed of 250 different services, you're not going to have a unique, focused team for each microservice. So when kind of reality meets theory, you've got to figure out what to do with that, right? Do you use less microservices? Do you kind of group them together a little bit more than maybe you would like to? Or are you really ruthless about, look, I'm going to finish this service and then we're not going to touch it again ever? How do you distribute your team throughout your services in order to get your application up and going when the number of team members may not be large enough to kind of give the focused attention to microservices that you would like. So there are limitations to how you can do this, of course, depending on the type of organization that you work in. So, should you use microservices, right? Is this the hammer that's going to turn every screw into a nail? No. If you've got solid, CI, your testing is automated, and by automated, I mean nobody does anything. No human is involved. I don't mean like I push a button and it runs the test suite against the application that I just spent 2 days deploying. That's not automated testing. Automated testing is, by my definition, somebody checks in a piece of code, the tests run, and they tell you what happened, right? So if you've got that going, right, then you're probably in good shape. And if you've got an application that you're looking to scale, or they have a trouble scaling, or that you're having trouble sort of maintaining as a monolith, go for that. But if you don't have something like automated testing, don't worry about microservices. It's not going to help you. It's probably going to hurt you, right? There's a lot of things you've got to do right and do well for microservices to pay off. If you don't have a fairly robust CI infrastructure, if you're not kind of pretty far down the road of doing things like continuous delivery, then it's probably not the first thing you should tackle. I say probably because it's hard to be definite. You've got to be really good at automated deployments. You've got to be really good at testing and monitoring to really get the benefits of a heavily microserviced application. So it's not a magic hammer that makes bad culture, bad architecture, bad code. It's just as easy to write a shitty application with microservices as it is with a monolith. In fact, it's probably easier, right? So beware of that. This is not the thing that will bring happiness and joy to all of us. But should you try it, right? One of the best pieces of advice I've heard is, if you're just starting out with a new application, don't go all crazy with kind of microservicing it to death, right? Because chances are you don't understand the boundaries yet. Now, if there are certain problems that you've solved before and you understand and so on, and you feel very strongly that ought to go in its own service, that's all well and good. But keep in mind that changing the service boundaries can be expensive, right? You're essentially changing APIs. So now, if you do that, you've got to figure out, am I going to be backwards compatible with my old one? Am I going to go rewrite the clients that are using my microservice, for other people to maintain that? Do I run multiple versions of this service so that it's backwards and forwards compatible? All of those things. You are better off letting the kind of the general domain of your application settling a little bit before you go whole hog, trying to create a bunch of different services. You've got to be good at infrastructure provisioning. Right? If you're not good at saying, I need a cloud of X servers in it, I'm going to deploy all of these things to it and press a button and 5 minutes later it's done. If that isn't a self-service kind of activity in your organization, get good at that first, because you're going to be doing a lot of that if you're testing and building microservices. You've got to be pretty good at rapid application deployment. Right? Unit testing is fine, right? You're going to stub and mock and all of that kind of stuff. But once you get down the road a little bit, where you need to do a little bit of integration testing, a little bit of system testing, you've got to be very good at this. You've got to be really good at monitoring. Monitoring becomes much more important in a microservices application, and we'll see a couple of examples of why that is. And you really have to have a good kind of domain system level comprehension of your application, because the understanding of the domain is going to shape a lot the way that you break out the various services from each other. And that's also a benefit of using microservices, quite frankly, because in order to do a good job, you need to have good system comprehension. And to the extent that going down the microservices road forces you into that understanding, and of course, if you try to do it without that understanding, good luck. But it forces you down that road of better understanding, and that's always a good thing. So what's difficult about them? Well, distributed systems are hard, right? I've already gone through a bunch of these things. Service composition is tricky to get right. It can be expensive to change. And of course, the further down the road you get, the more expensive it is to change these things. What was a method call in process is now an over-the-wire call. So you're marshalling on marshalling. You're dealing with services not being available. You've got to do, service discovery in the first place to figure out where the heck is the endpoint that I need to talk to. So you've got to care about that. Whereas before, maybe all you cared about is, what's the JDBC connection string, right? Now you've got a lot more sort of state that you need to inject into your service at Bootstrap, so it knows knows who to talk to. The abstractions that we come up with might look great on paper, but they might be huge, massive bottlenecks. So be careful of that. I mean, there's a reason. Somebody described a great example to me a few weeks ago about, if you think back to Windows 3.1 and games on Windows 3.1, they were blazing fast, everybody loved it, and then out came Windows 95, and all of a sudden you couldn't write directly to the screen, you couldn't write directly to the memory locations, and all the games sucked and were slow because of this layer of abstraction that had been created, and of course everybody freaked out and was unhappy about it, and then came DirectX. Right? So the idea was we need a separate API to more efficiently do the types of things that we need to do. Sometimes just throwing an abstraction in can be very damaging for performance. So be careful about that and understand, how often do I make this call that is today a method call? If it's twice a day, no problem. If it's, 200 times a second, do you really want that to go over the wire 200 times a second? So you have to think about those kinds of things. Service discovery I talked about a little bit. State management becomes way more interesting, right? You've got to worry about transactions now. If I commit a bunch of data, do I actually own this other piece of data that I'm now about to do a commit on? Or is that owned by another service? Do I need distributed transactions? Lord, I hope not. Stay away from that if you can. How do I do caching, right? How do I do, how do I take my kind of monolithic, nice single schema in the database used by my nice monolithic, piece of code, and now I have to tear it apart as to where, some objects are managed by this service, other objects are managed by that service. If there are no foreign keys between those two sets of tables, you're probably in pretty decent shape. But if there are, now you got to worry about how to deal with that kind of stuff. And then, kind of what I alluded to before in terms of, service team kind of structuring. Do you have a team per service? Or does this turn into a silo per service? Because if you work in a company with crappy culture, it easily becomes, well, that's their problem. They caused that. That service is at fault, right? Instead of, our application isn't performing as expected. Let's figure out what the problem is. Let's root cause analyze, fix it. Those kinds of things. And you've got to deal with Conway's law, right? If you've got X numbers of teams, are you going to end up with X numbers of microservices? And is that the right, structure? For you to have. Along the way of, if you ask 4 teams to build a compiler, you get a 4-stage compiler, those kinds of things. And then, of course, the big question for a lot of us, which is legacy apps. What do we do, right? We've got monolithic applications. We'd like to modernize them a little bit. Are we going to rewrite them from scratch? Probably not. Are we going to ignore this whole microservices thing entirely? We might. Maybe we don't touch this app anymore. Maybe all we do is bug fix occasionally. Maybe it's not important that we make it more modern. But likely what we'll see is a bunch of different approaches like hybrid applications that are partially microservice and partially monolithic. We may start carving away pieces of the monolithic application into separate services as we decide that we need to scale this piece. So let's carve it out if we can. So we'll see a little bit of that. And along that comes the difficulties around how do we do deployments of hybrid applications, et cetera. And again, good system comprehension is key. Having your architects or whatever title you give to these people whose job it is to keep a significant enough picture in their head of the entire system is pretty important. And you might have a small service, but what's the size of the deployment footprint, right? If your service is a WAR file and you're required for whatever reason to deploy it into WebSphere, yeah, that's cool, but that's a pretty big deployment footprint. What if that instead could just be a very simple little web service without all the J2EE stuff and all of that that comes along with it? So you got to think about that. A few best practices, which I forget. Is this one I hand off to you, or do I keep going? I think I keep going. Good answer. All right. So what makes a good, candidate for a microservice? Loose coupling, right? If I need to make a change to service A, and that forces me to make a change to service B, those things are more highly coupled than I thought. You want to sort of think about that. Small, tightly focused APIs. A microservice with 600 different REST endpoints. Probably not as micro as you intended it to be. Now maybe that's a front-end microservice, right? Maybe that's some sort of umbrella microservice that you're using, and it delegates to all sorts of different microservices on the back end. Maybe to make service lookup easier, maybe to make security easier, what have you. That's fine. you always want to have high cohesion inside your microservice. We don't have, having a microservice that's going to talk to, a bunch of LDAP servers and a bunch of databases and a bunch of, key value storage type things. You start to, that starts to feel a little bit weird. We're using lots of different technologies in one service. What's going on? Is it really the kind of service where we need to do that, or are we just doing a bunch of different things in one service and we should split it apart? So. Obviously, domain-specific behavior ought to be in one place. If I have a profile service, put all profile-related things into that service as much as you can. If you need to change a behavior, you shouldn't have to go touch multiple services. If you do, then there's something going on. So, what size? What's the right size for a microservice? It's a tricky question. The smaller the service, the more benefit you get from the decoupling. That seems like a true statement. General rule of thumb is you ought to be able to rewrite the service in a small number of weeks, and I put small in quotes just because 2 weeks is small to some and 8 weeks is small to others. It just sort of depends. If you can't make a change to a service and then deploy it kind of seamlessly, it's too big. There's some concerns in there that should probably be factored out into a separate service. But of course, the smaller the service, the more moving parts, right? And do you have the right software pipelines set up to handle this level of kind of serviceness? Do you have the ability to test all of these things automatically? All of those kinds of things apply. So I've said this before. I'll say it again. If you're doing lots of manual testing, address that first. Don't even think about going down the microservices route. Don't think about continuous delivery. Don't think about DevOps. Don't think about anything fixed to manual testing. That's generally one of the biggest areas of kind of slowdown and problem that we see. Unit testing, big time on the unit testing, of course, and kind of service level testing, light integration kind of testing with other services mocked or stubbed out. The further along, you want to sort of do the traditional thing, kind of the testing pyramid, where most of your tests are unit tests, some of your tests are integration tests, very small amount of your tests are system tests, as much as possible. That's easier said than done for some applications. This is true, but kind of do the best you can. Of course, you want to have kind of a single pipeline for your end-to-end tests or system tests, right? So everybody's microservice pipeline feeds into an end-to-end testing pipeline. That might be separate from the pipeline that you have to go through to do a deployment for your microservice, but you gotta feed all of these changes in at some point and make sure that they all work together. For some organizations, quite frankly, that kind of testing happens in production, right? Deploy it. If it works, great. If it doesn't work, roll it back or roll forward. Or do a canary deployment or do a green blue or something to allow you to do that. Performance testing is going to make a difference, right? Because any sort of hotspots, in terms of function calls and those kinds of things that you have in your application will become way more of a hotspot if that call now goes over the wire. So you need to pay attention to those kinds of things. And if you've got flaky tests, they're going to be amplified by a bazillion in a microservices architecture, right? Because you're now going to have much more, especially in your integration or system level tests, you're going to have much more variability in terms of timing and those kinds of things. So flaky tests, as always, are the devil. A little bit about environments and deployments. Keep the environments for your development, for your testing, as close to production as possible. That's easier said than done in some cases, but do try. Do X as code as much as possible. That will obviously help you. One service per host. Minimizing the impact of one service on the other minimizes the impact of host usages. Use VMs and containers to make your life easier. Containers, Docker and microservices are sort of peanut butter and jelly in many ways. They're both, kind of out there to do one thing and do them well. So they're very frequently used together. They map really well. Immutable servers, I think, is more and more, or immutable, production servers in particular, is more and more a pattern that we see. We have customers who, once they do a deployment to a server, they throw away or destroy the credentials. Nobody logs into that. No service, no human, no nothing. You don't fix a service, you repave, right? That's a pretty good way to keep drift from happening in your production environments. And of course, the platform as a service systems out there are there to help. But that can also lock you in to a particular deployment technology or a particular kind of deployment architecture. So that may matter to you, it may not. And of course, automate everything. No human involvement needed in these kinds of things. And then, I sort of referred to this a little bit before, but do we worry more about mean time to recovery or mean time between failure? Are we okay with testing in production? A lot of organizations are, because they're really good at mitigating problems. They're really good at rolling back. They're really good at rolling forward. So there comes a time when a ton of system testing may not bring you enough benefit to warrant the amount of time that it takes to do it, and you may be good enough at doing canary or blue-green or rolling deployments or what have you, that you're better off just throwing it in there, and if it doesn't work, toss it out, start again. But monitoring is definitely your friend and ally in that case. And another interesting thing about services is they don't really necessarily need to have the same kind of durability requirements, right? For sure, your shopping cart service had better be running all the time, but if your avatar loading service has a little hiccup every once in a while and people don't see their gravatar, they see a random generic picture, is that going to impact your revenue? Is that going to impact customer happiness? Those kinds of things? Probably not, right? So you don't necessarily have to have the same strict, stringent standards for all of your services. That's not a license to write crappy, unreliable services, but use it, use it wisely. So breaking apart the monolith. Obviously don't do a big bang rewrite. Those things, take forever, and you never end up with the same functionality that you had in the first place, and it just pisses everybody off because, their favorite, feature, which of course was only used by 5% of the people, so, we decided to, leave it out till the next version, but of course, everybody is in some 5% categories. Now everybody's pissed off that their favorite feature is gone. But if you're looking at the monolith and trying to figure out what to do with it, look for seams, look for areas of code that are sort of naturally cohesive and independent from other pieces, and sort of focus on those. Having a good idea of what your domain is and using domain-driven design, which I'll gladly admit I'm not an expert in, but I've seen enough people do it that it's a fairly useful thing to do in this particular case. Look for areas of code that you're changing a lot or that need to change. Right? If you're in an area of code all the time fixing problems, maybe this is something that needs a little more TLC, and maybe it's also an opportunity to pull something out as a separate service. Don't ignore your organizational structure. It may not be a big win to split a service in two if you can't add a team or take a bunch of people and work on that service independently. It may not buy you anything. So think about what you're trying to achieve by breaking a service in two, or breaking off a piece of code off of a monolith. Dependency analysis tools can help in terms of figuring out what code calls what code, but they're not going to tell you where the right boundaries are. So they can be helpful, but they're not necessarily a panacea. And probably the most difficult thing that you'll deal with is data, especially the RDBMS. You need to understand your schema. You need to understand where are the foreign key constraints. What are the pathways to mutating certain pieces of data. What service needs what view of what data when, who owns that data, all of these kinds of things and transactional boundaries you need to worry about. And then is eventual consistency okay? Is this a bank transfer where we do want to kind of a high acid kind of commit on that, or is this just showing a news feed on a Facebook-like site where who really gives a crap if I miss an update until I hit F5? That's okay, not a big deal. Split data before you split code is another good idea that I've seen implemented. If you don't understand your data and you start to split your code, you're in for a world of hurt because you're going to be trying to do manipulations on data that your service doesn't really own. And now you've got data consistency problems or rollbacks or deadlocks or things you need to deal with. And of course, always ask, does this need to be an RDBMS? An RDBMS is a heavyweight kind of thing to use. If you need it, you really need it. But if you don't, consider using an alternative. Consider some sort of NoSQL, key value store, that kind of stuff. That can be pretty important. So things to look out for. This is not necessarily easier. Microservices are not necessarily going to be easier. It will bring a lot of benefits if done properly, but there's complexities that are introduced for sure. Your services are going to evolve over time. You split them, merge them, move things around. So just acknowledge that and act accordingly. You really have to be rigorous about handling failures because now, again, what used to be a simple method call is now going over the wire to somewhere. So there are great libraries out there like Hystrix from Netflix to provide things like retries and circuit breakers and fail fast and those kinds of things. Your reporting may need to change. Your data may not be in the same layout or structure that it was before you broke apart the monolith. So you need to keep that in mind. And then the network is reliable and all of the other fallacies of distributed/network computing, infinite bandwidth, no latency, all of those kinds of things. Keep those in mind because you will be suffering from all of them in your microservices architecture, even if you're sitting on a really fast backbone in your data center. Be careful about how you expose objects over the wire. Maybe you're exposing too much. Maybe you're exposing internals. That didn't really matter when it was just a domain object in memory, right? Maybe there was an API that you threw across that object that allowed you to, guard a certain internal state very simply. But now you're throwing it across the wire as, JSON or XML or something like that. Everybody can see what's out there and might make assumptions about what they can and can't do with it. So be careful about that. And then you've got the whole sort of service dependency versioning thing to worry about that you didn't necessarily have to worry quite as much about before. Consistent logging and monitoring is really, really important. We're going to talk a bit about that. Avoid premature decomposition. I think I covered that already. Event-based techniques, sending events instead of having RPC-like mechanisms is very powerful and helps you scale and all kinds of good things come out of that. So look into those things. And then in terms of inputs and outputs, be conservative in what you do and liberal in what you accept from others. That way your services are going to be more loosely coupled from each other as they evolve, which is always a good thing. And now we're going to talk about best practices for microservices and monitoring. Dawn.
Thanks.
As usual, I spoke too slow.
All right, so I will try to rush through this, but Anders has given a good overview of how you can break apart your monolith and come to microservices, but once you're there, monitoring is very important. It comes into play, and it's more challenging, more complicated than you're going to see in your monolithic application because you do have the different connecting points, the integrations between your services that also need to be monitored. You have these distributed systems where you want to have one host per service, and so it just adds a lot of complexity and a lot of change to how you're monitoring. So this is just a quick fun picture. You want to make sure you catch that before your ship of containers falls over. So how does monitoring change? Monitoring in a monolith is easier because really if you have a problem, whether it's a slow web page, some error you're seeing or weird behavior, you're always going to be coming to the monolith. That's what caused the problem. Maybe finding the root cause will take a little while, but at least you know where to start. When you have that large number of microservices, tracking down the root cause can be more challenging. A single end user request could touch dozens of services when it's being served, and so how do you find where it is that the error was introduced? Is it a timeout, connection timeout between services? Is it something, a cascading error that went across a number of services? So what you really need to do is change the way you're monitoring and you're thinking about monitoring these services. So this is a tweet that kind of highlights that, where you don't want to be in this situation where you're trying to solve a murder mystery. You want all of the data to be there so you can get to it. So in general, all services should log and emit monitoring data in a consistent fashion. So regardless of what tool stack each service is running, it could be different across the teams, across the services, but the format should be consistent so that you can aggregate all of that data and search based on different fields in one place. Aside from just monitoring your services, you want to also look at the latency and response times between those services. So because what used to be perhaps a procedure call in your monolithic application is now actually being called over the network, where you get those the bandwidth, the network latency, things like that come into play that need to be watched. Aside from these things, you also want to make sure you're looking at your host, the CPU memory. While if you see one host have a spike in CPU usage, that might be just on that server. If you see a pattern across multiple hosts, then you might track that down into the services causing this. And so being able to aggregate that monitoring data into a single place is important, so you can look for those patterns across your services, across your hosts. And using different cloud providers for those hosts can actually do that monitoring for you, so you don't have to do extra work around that. Make sure you're logging early, logging often, you're collecting all of the data required so that in the end you can solve that murder mystery, go in and find the data that takes you to the root cause of your problem. Aside from that, not only looking at errors, but understanding, okay, when my service is behaving well, when it's healthy, what should all of these metrics look like? So that when you have an issue, not only can you maybe see yourself coming towards an issue before you're in a bad situation, but also you can easily identify what caused it. What is the thing that looks off from what my healthy system is supposed to look like? And one technique that we recommend is using correlation IDs to track requests through the system. So when the first user requests come in, that service adds a unique ID to the request, and then it's passed along in the headers in some fashion to all of the subsequent services, so that when you're then looking for that root cause where a request went through that dozen set of services, you can aggregate the data, find all of those requests that have that ID, and start there. And services or tools like Dynatrace actually allow you to do this for you, where you don't have to code it into your services, but actually Dynatrace will add that ID and pass it along in all of the subsequent logs. So I know I'm very close to out of time, but let me just touch, I can touch on this really quickly. This is kind of near and dear to my heart, is how you're setting up your delivery pipelines around microservices. There's a lot here, but I think the key points are you want to really automate everything. You want your your delivery pipeline to be your friend, where it's one orchestration platform that is calling all of those pieces, all of the that are part of your stages as you in your path to production. I know Anders has talked a lot about test coverage. That make sure your tests are automated. And look at using self-service automation, where anybody can come in, whether it's dev or QA, come in and automatically provision and configure the environments that are required for your testing or your deployments. Use things like chat ops for making this easier and track what others have done and repeat that. This will help you reduce your onboarding time for new people, new environments, as well as the complexity involved. Your pipeline should be that one place where you go to see where am I in the process. It gives you that real-time view of where you are. Am I still in CI? Am I waiting for someone to approve this to go into my UAT environments? Am I waiting on a dependency on another service that's not ready yet? So you can go in and have that one point of visibility, and then if needed, dig in deeper to find out what is causing this, what are the details of my current status. And then hook this back into your monitoring so that your alerts in your monitors can trigger actions in your pipeline itself. If your service failed, automatically trigger that rollback or that change between your blue and green deployments. If you're reaching the limits of your current capacity, scale your environment automatically. So having all of these pieces automated and triggered by when you see things happen just makes it so you can click run and let go and let it all happen. So in terms of isolation and making sure that you have the autonomous development process for your single microservice, the recommendation is to have one repository per service. I think Anders had talked about if you have that shared code, make it artifacts or binaries rather than code, and then otherwise have your one repository per service. Then it feeds into your one CI and deployment pipeline per service. So the goal is to be able to independently deploy your one microservice and have your pipeline set up as such, whether it's a shared pipeline that can handle the delivery of just one service or one pipeline per microservice. Automate everything underneath, from provisioning your environments to the CI, to running your tests, to your deployments, and everything in between. So everything should be automated, and then you have this one tool above it that is orchestrating the entire process along the way. You want it to be tools and environment agnostic. You're allowing the different teams to use the tools they choose, but you want your pipeline to be kind of more generic and able to push you through that process, but more data-driven and parameterized based on the microservice that's being deployed and then plugging into the correct tools. And then test automation tools, service virtualization. I think Anders touched on, stubbing out the connections between services so you don't have that dependency on all services being up and available in order to do some light integration testing. So again, the tracking is about the visibility, having your pipeline be the one place where you go to see exactly what happened, who checked what in, what tests were run, where was it deployed, who manually approved something, so you can go back and have that one place where everything is documented. You can also then bake in your compliance, your security tests and acceptance tests into that entire pipeline. Have that part of your automated process so that those can trigger automated gates where, if you pass your certain compliance tests, only then will it automatically promote you to the next environment. Maybe promoting all the way to production, you need someone to actually come in, take a look at what has happened, and manually approve it. So have both of those capabilities. And again, one thing that we really believe in is having those reusable components rather than repeating the very similar or same code across your pipelines, making those reusable components or pipelines that are data-driven and parameterized. So this is just kind of the journey that we have seen from having one service per box back in 2002 all the way to why running on containers is really what we're seeing the pattern, and as Anders said, the PB and J of microservices. So while one service per box was very expensive and difficult to maintain if you have multiple microservices right at that time, but we've seen the progression where we went into virtualization. You might have one VM with multiple services running in that VM, but that's really not meeting the goal of the isolation that we're looking for, where you can have conflicting versions, one service taking up resources, or finding out that really one service ultimately has to run by itself. And so we moved on and have multiple VMs with one service in each VM, but then again, you're going to see with the VM the overhead of the operating system running in each of those. And so where we see things now is using containers as being really the right fit, where your container is going to allow you to run your services in isolation, have that network isolation, but without having the overhead of having those multiple OSs as well. So Anders said that microservices are about running, doing one thing and doing it well, whereas containers are about running that one thing and doing that well. So they really fit together, it just makes sense. So I know we went quite over on time, but yeah, okay. So yeah, great. We have a list of resources here for you to take a look at, and otherwise we can open it up for questions.
So we still have a couple minutes for questions. Can I ask if you could do microphones? So I'm starting to work in an area where we're moving from platform 2 or client-server type workloads and moving into microservices, and thinking about how do we model microservices? How do we look at historical data and maybe help us predict how microservices might behave? I'm kind of curious what your thoughts were on how you might consider that.
Yeah, I think, I'm not sure that many people have sort of gone, completely crazy on that yet. But you could certainly start to look at things like, where am I getting calls from, right? What tables are being touched by what queries, and what's the stack at that point, right? I mean, you could probably do some pretty interesting analytics on just understanding, of all my code and all my data, what are the hot zones? Because that probably will be kind of a guide for how you might want to split things apart. So a very nascent area, clearly.
Hi, Paul Krizak with Qualcomm. One of the things that we've been experimenting with microservice architectures is actually we're staff limited, so we are unable to have like a team that runs Elasticsearch, for example. But what we've done is created kind of a library so that anyone can have a little tiny Elasticsearch inside their app that they don't need a team to run, but there is a published version of it that they can run on their own hardware and on their own Rancher cluster or something. Do you think that's a best practice? Does it sound like is that crazy? Are we going to end up in no man's land in a few years?
I mean, I think anything that lets you, that gives you some goodness without too much badness, ROI, I think is the shorter way of saying that, is fine. I mean, I think there are certain things that just you aren't going to be able to scale the way that you do the code because you can't scale the team that way. And so working in those limitations, if that's an adequate compromise in the sense that everything we do is a compromise and a trade-off, that seems fine to me. That doesn't necessarily ring any bells. So
Thank you.
Yep.
Hi, Aurélien Gasser, Stack Overflow. You mentioned that testing for performance is more important with microservices than with monolithic applications. Could you maybe expand a little bit on that? Why is that so?
Sure. I mean, in some sense, it's really depending on the boundary that you're looking at, right? It's really no more important than it was before because ultimately the experience that the end user has is what counts. But you are going from a place where you're doing an in-process method call to where you're doing an over-the-wire call, and and marshalling and unmarshalling, right? So there's now added load in the system as a whole than there was before. So you want to understand that, and and I think I mentioned this before, but if you've got a hotspot where you're making 200 calls a second to a particular service, you may want to reconsider that. You may want to do those as batch requests. You may want to maybe the service boundary is not in the right place, but understanding understanding on an end-to-end kind of traversal for a particular request, where did we spend the time? Because once it comes time to figure out, where your performance problems are, once you're in production and people are screaming at you, you can't just throw the code into your kit or whatever the analyzer of your choice is and say, oh boy, that's the hotspot, because you don't know where it is. And so understanding the characteristics of where the latencies are introduced and those kinds of things are pretty important. And then also understanding, being resilient in the face of timeouts. If a service is down, how do you behave? Do you do a blocking call where you don't return until that service comes out? You might run out of resources that way, or do you have a circuit breaker type methodology where once you realize that service is down, you fail fast, right? There's lots of things like that you have to worry about that you didn't have to worry about before.
Well, thank you very much.
Thank you very much.
Thanks.